Hello, this is Eric with Easy Science, science explained as simply as possible. Today we're going to talk about Archimedes Principle. So, Archimedes Principle says that the buoyant force of an object is equal to the weight of the water displaced by that object. Now, if you're not very science savvy, it may sound to you like I just said, Archimedes Principle says that the blah 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 blah. So let me try to simplify things and clarify them a little bit for you. What Archimedes' principle really is a statement about the relationship between an object's density and whether or not it sinks or floats in the water. This explains why a piece of cork thrown into the water will float, but if you take a rock of about the same size and put that into the water, it will sink, well, like a rock. To explain this, I'm going to use the very extreme example of the battleship USS Iowa, which is 3 football fields long, and it weighs 45,000 tons, and it's made of steel. How is it that this ship can possibly float, and easily, I might add? Well, the answer to this is related to volume, and the simplest definition I can come up with for volume is how much space an object takes up in the universe. So, on the left we have a picture of a bottle of Coke, and if we can imagine that is a 1-liter bottle of Coke, then that's the volume of the bottle. The bottle takes up 1 liter of space here in the universe. And everything that exists takes up some space. Now imagine that you were taking a bath, okay? And you've never taken a bath before, and so it doesn't occur to you to not fill the bath up all the way. So you fill the bathtub all the way to the very top, so there's not even a millimeter of space left in that tub. And then you get into the water, and naturally the water is just going to overflow everywhere. So a human doesn't take up 1 liter of space. A small human, say the size of a middle school student, takes up about 62 liters of space. Now, a larger human will take up more liters of space, and then a smaller human will have a smaller volume. But if you fill the bathtub all the way to the very top, and then you get into the bathtub and sink yourself completely under the water, then a bunch of water is going to come out. And how much water will that be? Well, as much water as the amount of space that you take up. And since you, hypothetically, in this scenario, take up 62 liters of space, that means that 62 liters of water has come out of that bathtub. Now, that 62 liters of water weighs 62 kilos, or 136 pounds, because a kilo of water is about 1 liter of water. So the rule is that if that volume of water that you've displaced and put onto the floor, that 62 liters of water, weighs 62 kilos, if you weigh more than 62 kilos, you will sink. If you weigh less than 62 kilos, you will float. So why does the USS Iowa float, this giant steel ship? I mean, steel's heavy, right? Let's imagine that we put the entire USS Iowa in a giant bathtub that is 400 or 500 meters long. And we're going to fill that bathtub all the way up to the top. Once we've done that, we are going to push the battleship Iowa completely under the water. And a bunch of water is going to come out. How much water is going to come out? I actually don't know, to be honest. The volume of the USS Iowa is huge, and I don't really know how I could possibly estimate that volume. But needless to say, an enormous amount of water is going to come out, and that water is going to have just a ridiculous amount of weight. How much weight will it have? Well, the answer is the battleship is going to weigh 45,000 tons, and the water is going to weigh a lot more than the battleship. If the water weighed less than the battleship, then the battleship would sink. But the battleship weighs less than the water. How can it possibly be that a battleship that's 45,000 pounds weighs less than this volume of water? And the answer is that the USS Iowa, like all ships, are mostly hollow. They're mostly air. Sure, the outside is made of steel, and there are some decks and stuff on the inside that have frames made of steel. But most of the inside of a ship is going to be hollow. And so as a result, if you were to push that battleship all the way under the water in the giant bathtub, the water that it displaced would be heavier than the battleship. And as long as that's true, the battleship will float. Now, if you torpedo the battleship or hit it with a bomb or some kind of large gun and put a hole in the ship and now starts to fill up with water, well, then it will sink. You know, as the engineer said in the movie Titanic, I assure you the ship is made of steel. It can definitely sink. But it won't sink as long as you don't fill it up with anything heavy. So I'm going to go over this again for the sake of clarity. Imagine that you have a black cube, and that cube is exactly 1 cubic centimeter, meaning it's 1 centimeter in all directions, 1 centimeter tall, 1 centimeter wide, 1 centimeter deep. So we're going to put that in some water. Now I can tell you that that same cubic centimeter, if it's made of water, weighs 1 gram. So if this black cube weighs more than 1 gram, then it's heavier than the water and it's going to sink. If that black cube weighs less than 1 gram, it's lighter than the same volume of water and it will float. And if it is exactly 1 gram, then it won't sink or float. It'll just kind of sit there suspended in the water. So that's what Archimedes' principle is saying when it says that the buoyant force of an object is equal to the weight of the water displaced by that object. Well, that's the basics of Archimedes' principle. I hope that it helped you. If it did help you or you enjoyed the video, please like and subscribe, and also comment on what other topics you would like an easy science video about. Have a great day.